Okay, so when you search up the website, you'll be taken to our homepage where you will see a map view and a list view of the refineries across the US. So list view, you're able to search a specific refinery. Map view, if you're looking for like refineries in a specific area, then you can zoom in to that area. So we're going to zoom in real quick. And then these different black dots represent the refineries throughout the US. So you can hover over to see which one that you want to select. We're going to go to the Marathon Los Angeles refinery. Then you click Get Available Data. It will take you to our new dashboard for that refinery. And then in the upper right-hand side, you can choose the year. We'll look at 2018 data. And the first thing that you'll see is this bar graph. Each of these bars represent a refinery in the United States and their most common benzene level. So this yellow bar right here represents the refinery that we're looking at currently, but the blue bar you can hover over and select another refinery to compare. On the right-hand side, it'll show that most common benzene level. So in 2018 for the Marathon Los Angeles refinery, it was 0.7 micrograms per meters cubed. And then comparing it to another refinery, you'll see that it was 0.9 micrograms per meters cubed, and you're actually able to click on the link to go to that refinery. And just to preface, the most common benzene concentration, that is essentially an average, except we're not using some of the extreme outliers that may skew that data. When you scroll further down, you'll be able to see this map where you can zoom in to the different sensors. Each of these dots represents a sensor that is collecting data around that refinery. And they'll vary in color based on the percentage of unhealthy readings that that sensor collected throughout the year. So the most common benzene concentration was an average of those. These are showing all of the different concentrations or all of the measurements taken throughout the year. So the yellow dots will have a 0% of that unhealthy level, which we're considering an unhealthy level to be above 3 micrograms per meters cubed. And then they'll start to get to a darker yellow or even an orange or red color if they're a higher percentage of unhealthy readings. So for sensor 15, you can see on the right side, 12 out of 25 measurements were at that unhealthy level. When you scroll further down, you're able to either compare the refinery or add it to your watch list, and then you can download the data directly from that dashboard. So highlighted in yellow will be the benzene 2-week measurements. That's what you're able to download for this refinery. But we also decided to highlight which pollutants are measured or not measured and could be present at the refinery, but we don't have access to. So for this one, it has a box for the ones that have the boxes that are highlighted in gray and then have a slash through. Those are being measured at the refinery. They're continuous measurements, but we don't have access to that data. The ones that aren't highlighted but have a box with a question mark, those pollutants could be present, but they're not being measured at that refinery. And then you're able to directly download that here. But before we download, I'm going to go to one more feature on our website, which is the comparisons. So if you click up the top, comparisons, and scroll down, there's a few different ways you can compare the refineries. You can compare them by refinery like we were before with the most common benzene concentration. And then you can also compare by corporation, by state. So when you compare by corporation, yes?
If one thing to note is that there are little those little arrows
Yes.
there let you order things by that column. So if you go back to compare by refinery and you click the little arrow by most common benzene concentration all the way on the right, it will that's the lowest one to the highest one, and if you go the other way, it will be the highest to the lowest.
Yeah. And you can do the same for the other metrics of comparison. So on compare by corporation, if you want to see who has the most refineries in the what we're considering to be the worst refineries based on the most common benzene concentration, you can do that and see that Valero has 5 in the 20 worst. Then you can also do that for the average percentage over 3 for that refinery. And that was that unhealthy level I was discussing before. You can see Pemex has the highest average percentage over 3, and then specifically for Pemex Deer Park Refinery, their percentage over 3 is 50.2. And then when you go to compare by state, they're the same metrics they can compare by. So you can look into the specific state to see how many they have in the worst refinery. And then I want to highlight a little symbol that we have over here on the left-hand side, the little with the 20 in it. That is highlighting which are in the 20 worst refineries or the 20 least wanted. So it has one out of all of the refineries in the US, it has the highest, one of the highest, most common benzene concentrations, it top 20 worst. And then lastly, you can compare multiple refineries at once. So if you want to look at a specific state, go to California, and then a specific corporation, you're able to do that. So we're just going to download one for now. We'll click that one. And you scroll down, you're able to select the dates that you want to download for. So we'll just download for January 2021 to January 2024. And then you're able to either download it as a CSV file, a JSON file, or access the data directly with an API. I'm going to do CSV so I can show you what it looks like. Then you're able to go to that. And when you open up that folder, you'll see 3 files. You'll see the net concentrations, the data taken, and also the data dictionary. We're going to go into the data first. And that will show you all of the benzene concentrations within that time period you selected. You might notice what usually happens is these pound marks will show up in a column. All you have to do is double click to extend that column to see the dates in that. And it's just because the column was too small to show that data in the column. And then we'll also go and look at the net concentrations. And so what I was showing you before was the specific measurements. This one is showing the average delta C, which is a metric used by the EPA. And what they do is they take within the 2-week period, they subtract the highest measurement minus the lowest one. And again, you can extend these columns to see the dates. If you're looking through them and you're confused, you know, what one of these titles means, that's when you can go to the data dictionary, open that up. And that will show you what we're defining the column names by. So facility, name of facility, and so on. Just to show a way that you can use the tools on our website to analyze a specific refinery, I decided to go in and do it for the Lyondell, Basel, Houston refinery. So with specifically working with the numbers, I went in and looked at the most common benzene concentration. So I didn't even have to download the data for this yet. I just went in and selected for each year and then put it onto this graph right here. And so you can see that from 2018 to around 2022, it's slightly increasing with this short dip in 2023 and then back up in 2024. So it started at 1.3 micrograms per cubic meter in 2018 and then slowly rose to 1.8 in 2024. And so that doesn't seem like a huge increase, but when you compare it to our metric of worst refinery, it's a little more concerning. So in 2018, it was actually the 25th worst refinery. And then it followed this similar trend of the graph where it slowly increased into becoming the 8th worst refinery. And even though its concentrations didn't change much, This signals that the rest of the refineries in the US might have gotten a bit better while this refinery continued to slowly get worse. And then another way to look at it is looking at the percent over three, which is that unhealthy level that we determined. In 2018, 16.5% of those values measured in the sensors were above that unhealthy level. And again, followed the similar trend up until 2024. Most recently, it was 27.5% above that level. And then when you look at our sensor map on the website, this can kind of clue you into, where these measurements being picked up. I'm not from the Houston area, so I don't know specifically why these sensors would pick it up. So after I talk this through, if anyone who's from that area knows, that would be interesting to know about. But just looking at this sensor map, you can see consistently sensors 1, 2, and 3 along the Buffalo Bayou have measured unhealthy levels. So they're close to that red level of being 100% an unhealthy level. And yeah, that's continued up until 2024 most recently. But then when you look at sensors 4, 5, and 6, those almost had no unhealthy readings in 2018, but then they slowly increased in 2021 to be 30%, and now half of those measurements have been at an unhealthy level in 2024. And so it'd be interesting to see, is that going to continue are those sensors going to continue to get more unhealthy levels, and will that spread to other sensors?
So using all of this data, we've finally formulated a national comparison, and this is really the first of its kind. There hasn't been any attempt to do this other than like a dashboard or individual investigations of specific oil refineries. So what's cool about this is that the dashboard that Sydney showed you is the building block of, like, these are the building blocks of the analysis itself. So the metrics that we're using are these benzene sensors, that percent over three, sort of, and then the most common benzene concentration that's also going to be used for our analyses. So there were three major results that I wanted to focus on for this presentation. One is our regional analysis of EPA regions. We also had this national change over time analysis, and we were able to look at hotspots along refinery fence lines to potentially identify places of interest for fence line communities. So our regional analysis, we basically took the mode and compared them against each other. And this comes out as one might expect. There were a couple of EPA regions that stood out as having higher modes on average. Those ones were Region 6, which is like the Texas and Louisiana area, and Region 8 and 4 also stand out. And this kind of makes sense if you look on the website at the comparison page. You can sort by the top 20 worst, and most often those are going to fall within one of these three regions. We also looked at change over time, and to do that, we essentially found the trend line of each refinery. So we plotted their modes out over time and then just plotted a line between them. And depending on the sign of that trend line, so like the slope, we were able to see if mode was changing over time or increasing over time, if it was relatively constant, or if it was decreasing. So I have three examples of that here. The HF Sinclair Navajo refinery has been like pretty notoriously bad from our analysis. But as you can see, it is decreasing over time pretty significantly. When you compare that to Pemex Deer Park, it has sort of a very moderate increase over time. And Valera Benicia in California, that one has stayed pretty consistent throughout the years. So when you take the slopes of each of those trend lines for each refinery, you can plot this distribution chart. And from this, you can see that like this line at 0 right here, close to this red line. I'll explain that in a minute. Most of the refineries seem to be decreasing slightly, and there's like not a huge correlation, but it seems like about half of the refineries in the US are decreasing and about half are increasing. So anything, this red line is the median. So anything below that is 50%, and anything above that is 50%. But it does seem like of the refineries that are increasing, they're increasing at a slower rate than the ones that are decreasing, if that makes sense. So like down here, this -1, that's the Navajo refinery, and then there's this like longer tail out here. So kind of interesting to see. Our last thing was that we wanted to look at hotspots, and this is essentially we just took the charts that we have graphed on Refinery Air Watch. So we defined hotspots to be sensors where unhealthy readings are disproportionately concentrated. So at Pemex Deer Park Refinery in 2023, there were 334 unhealthy readings across 24 regular monitors. So our idea was that if those readings were evenly distributed, each sensor would have about 14 unhealthy readings per sensor per year. And then there are two examples, so like if it's a hotspot or not a hotspot. So sensor 3, only 10 of the 25 measurements were unhealthy in 2023, so that would not be a hotspot. But sensor 23 down at the bottom here, 22 of 25 were unhealthy in 2023, so it is a hotspot. So some numbers for you. 61, if you look at refineries that have these like flagged hotspots year after year, 61 out of the 119 refineries have the same hotspot year after year. As you can see on the graph on the right, these refineries also tend to have higher modes or most common, depending on like how you're saying it, which kind of makes sense. So the worst refineries are going to have like the worst sensors. But 114 of the 119 total refineries have at least one hotspot across all years of data. So it seems to be the case that in almost every refinery, these benzene distributions are not equal. So potentially, fence line communities are experiencing benzene pollution at different rates depending on where they live or where they work. So in summary, certain EPA regions, the South Central, Southeast, and North Central regions show higher benzene concentrations. Most refineries show a small decrease in benzene concentrations over time, although there's not like a very strong correlation across the national database. And also, benzene is not evenly distributed across the refinery, indicating that some fence line communities may be experiencing worse pollution than others.